Hello and welcome to another video. My name is Vedran Kesagic and this video is about storage space capacity. We will calculate capacity based not on official documentation, because I don't know that any of it exists, but on certain tests I did and the logic that aligns with reality. So I think I figured out how it works and I will show it to you. So first, a few terms about storage spaces we will use. Column is a chunk of data written to one disk. We will mark it with the letter C, so number of columns. D is total number of disks. Disks written is basically a stripe. In one operation, storage spaces write to multiple disks. Or read from multiple disks. So they access multiple disks at once, depending on number of columns. Number of columns corresponds to number of disks. That makes storage spaces faster or more resilient, or both. So we have so-called disks per column and number of columns, and multiply that, you get number of disks written at once or in parallel. Types of virtual disks are simple, without any resiliency, but that is the fastest in both reading and writing. We have two-way mirror, which has a resiliency of one disk failure guaranteed, but it can even survive more than one disk failure if you are lucky. But if two disks die from the same mirroring pair, you will lose the data. So only one disk loss is guaranteed, but if you're lucky, you can survive more. So single parity. Parity is like RAID 5. So you have minimum of 3 disks, and basically it is slow. Good for archiving. We have more advanced types of resiliency in virtual disks, which can survive 2 disks failure, but they are even slower. So we won't deal with them here. I mean, we can calculate capacity even for them, but they are not used so frequently. Frequently asked questions from Microsoft page, very useful to read. Please visit this URL. One interesting table there is table with all resiliencies of virtual disks and how column maps to disks, physical disks. Usually, you have one column equals one physical disk accessed at once. For example, if you have 2 columns in simple, that means you will write to 2 disks at once, 2 disks in parallel. If you will read 2 disks in parallel, that means you will get speed of 2 disks, which is double. But for mirroring, mirroring is the only one with a ratio of 1 column to multiple disks. That means in mirroring, 1 column means writing to 2 disks or 3 disks, depending, do you have mirroring, two-way mirroring, or three-way mirroring. So that is the only where ratio is not 1-to-1 between disks and columns. Note that here we have a minimum number of disks, and it is for three-way mirror it is 5. For single parity it's 3. But for parity we also have maximum number of disks. So we cannot have more than 8 disks in parity, or 17 in dual parity. Very useful comments there. If you want to achieve optimal pool capacity, use multiples of the number of disks the storage space needs. That is a simple rule If you started with 4 disks and you lack capacity, it's the simplest to add another 4 disks, maybe bigger, and you expanded the capacity. That's a simple rule, but we will go beyond that here. We will dig into it completely and make it more flexible, so you can add any size disk and see what you can get from that. When you choose a column count, it's good to have to place column count one less than number of disks. That adds you flexibility. That's another comment there. Interleave is amount of space on each drive storage spaces allocates. Default 256 kilobytes. So stripe is data written at once. That means number of disks written multiplied by interleave. So that is stripe size. Stripe width. Stripe width is number of megabytes or whatever size written at once or read at once. Number of disks times interleave. A number of disks in a stripe, not total number of disks. So that depends on number of columns. Okay, let's see example. Mirror with 3 columns. Each column corresponds to 2 disks in mirroring. So that means with 3 columns we write to 6 drives at once. So disks written equals 6. Stripe width is 6 disks times space per disk allocated, 256 K, it's 1.5 megs. But actual capacity you get in mirroring is only half, because data is written to 2 places and actual data is half of the allocated space. That means you get 0.75 megs from one stripe in mirroring, in this mirroring. To illustrate, we have 6 disks here. Each disk with blue color is pair of the previous one. So you have the same data on it as the previous disk. That means we have 3 columns, but 6 disks. And interleave is 256 kilobytes, and this is one stripe of 3 columns. It writes to all 6 disks. You could have 10 disks, but in one go, in parallel, it writes to 6 disks all the time. Read 6 disks, write to 6 disks. So, if another example, parity with 6 columns. In parity, ratio of column to disk is 1 to 1. So 6 columns means 6 disks. One of these disks is for parity, and that alternates. It's not one disk reserved just for parity, but when it alternates, it rotates. And you get, it's very space efficient because you waste only one drive from capacity. You could have 10 disks here, but you would write to 6 drives at once, out of which 5 drives contain data and 1 is parity, calculated from the data for redundancy. So let's see how is speed affected with columns. If you have more columns, you get faster speed of that virtual disk. But then you have bigger chance to have unusable space left. If you have uneven size of disks, then you have a bigger chance to have unusable space, which you cannot use with this virtual disk, if you have high number of columns. But if you have low number of columns, you will probably use most of the space or all the space you can use of all the drives you have, but the speed will be lower, slower speed. And extreme would be to have one column, and that is very, very slow, but you can use almost all the space you have in disks. So because this number of columns is set only during creation of virtual disk, it's a property of virtual disk and cannot be changed. That means you need to think about this, what number of columns you actually will set before you create, because it's not available in GUI and it's unmutable, it's unchangeable. You need to do it from PowerShell and set it from the start good. If you need to change it later, there is no way to change it actually. You will need to create another virtual disk with correct number of columns, copy the data over and delete the old virtual disk. capacity, finally, how to calculate capacity. It depends on virtual disk type, simple, mirror, parity. It depends on number of columns, of course, and on disk size, of course. So let's see for simple resiliency, which means no resiliency. Example, if we have 2 disks, 1 terabyte and 1 terabyte, both are 1 terabyte, and in simple, 1 column equals 1 disk. If we have disks, for example, 1 terabyte, 2 terabyte, 3 terabytes, also all 6 terabytes can be used. But if we have 2 columns, then we write 2 disks at once. We cannot write 1 disk. We write always 2 disks at once, because that's set with column number. And if we have 2 disks, each 1 terabyte, we will use entire capacity. But if we have disks with 1, 2, and 3 terabytes, we will write again 2 disks, but how much capacity can we get out of that? Let's see in the demo. We have here 3 disks, physical disks. 1 terabyte, 1 terabyte, and 2 terabytes. If we have simple resiliency with 2 columns, that means one stripe writes or reads to the same number of disks, 2 disks, 2 disk stripe. That means when we allocate, we must allocate 2 disks at once. If we go from the biggest and count 2 disks, second one is 1 terabyte, has 1 terabyte of free space. So let's allocate 1 terabyte of free space on 2 disks, because stripe is 2 disks, from the biggest one. So let's start. So this is, we are allocating, this blue color indicates allocating of the first stripe. So in the first stripe, which is blue color, we have capacity of 1 terabyte plus 1 terabyte. In simple resiliency gives us 2 terabytes. Then let's allocate another stripe. We count free space. First, second. So 2 stripes. I mean 2 disks per stripe. So second disk is big, 1 terabyte of free space. So we allocate 1 terabyte of free space from there, and all previous bigger disks. Now in the second stripe, we allocated 1 terabyte plus 1 terabyte, 2 terabytes. That means total capacity is 4 terabytes. What would happen if we would have mirroring and not simple resiliency? Mirroring with 1 column is writing to 2 disks stripe, because in mirroring, ratio of column to number of disks is 1 to 2. So we have 2 disks in stripe. Basically, it is the same picture, but capacity of the blue stripe. So capacity of the blue stripe, I mean raw capacity is 2 terabytes, but we have half capacity in mirroring, and that's why we get 1 terabyte of space, which is redundant, written on 2 places. And the second green stripe also is the same, 1 terabyte, which is actually 2 terabytes on disks, but because redundancy, we have only 1 terabyte, and total capacity is 2 terabytes. All space is used, and we are good. Even though we have different sizes of the disks, we can use entire space without any unusable space and get full speed. Okay? All right. Let's see capacity for mirror and parity. In mirror, 1 column equals 2 disks in normal two-way mirroring. But same logic is as 2 columns in simple. You write 2 disks. with one column. And only thing is capacity is half, and we have redundancy. So if we have 2 columns in mirroring, we write to 4 disks at once, and it's same as simple 4 columns. So in parity, 4 columns, minimum is 3, but let's say 4 columns, we write to 4 disks at once, and one of them is lost for capacity, so we have capacity of 3 drives. Let's see the demo. Let's see how this looks for parity. In parity, 3 columns means stripe size is also 3 disks. Same number of columns. Number of columns corresponds to number of disks at once or in parallel. But we have 1, 2, 3, 4, 5 disks. One disk of 1 terabyte, 1 terabyte, 2 terabytes, 3 terabytes, and 4 terabytes. 5 disks of different sizes except first 2, which are 1 terabyte each. And because we are allocating or writing 3 disks at once, we need to do like this, calculation of capacity. So we start from the biggest free space, which is this one, descending. So 1, 2, 3. Third disk is this one. It's 2 terabytes. It has 2 terabytes of free space. So our allocation per disk will be 2 terabytes. And we will allocate 3 disks at once. First, second, third. Now we have blue stripe. It has 2 plus 2 plus 2, 6 terabytes of raw disk space, but actual capacity in parity is 1 disk less. That means 4 terabytes in this case. So 4 terabytes. Now on the second allocation, again algorithm is the same. We start from the biggest free space, which is 2 terabytes here, then 1 terabyte, 1 terabyte. Third one is this. It's 1 terabyte, so we allocate 1 terabyte in this second stripe in all disks, all 3 disks in a stripe. So this green stripe, it has 1, 2, 3 terabytes of raw disk usage, but we must deduct 1 disk, which is parity, so we get actual capacity of 2 terabytes from this stripe. Total capacity is 6 terabytes. And what is unusable space? This part of the biggest disk is unused, and this small disk is also unused, total of 2 terabytes. We can use that unusable space by creating, for example, mirroring with 1 column virtual disk, and it can use this space. Or simple resiliency with 1 column, and it can use 2 terabyte space. Let's see with 4 columns parity. The same disks and how to calculate capacity. Because of 4 columns, we have 4 disks in a stripe. That means we allocate 4 disks at once, or write to 4 disks at once, read 4 disks at once. That means we count to 4. 1, 2, 3, 4, from the biggest free space. So the fourth has 1 terabyte of free space, so our allocation will be 1 terabyte. 1 here, 1 here, 1 here, and 1 here. So this blue stripe gave us 1, 2, 3, 4 terabytes, but 1 less because of parity, that is 3 terabytes. Next allocation also starts from the biggest free space, which is 3 terabytes, and counts number of columns, 1, 2, 3, 4. So this fourth has 1 terabyte of free space, so our allocation will be 1 terabyte from this and all previous disks. 1, 2, 3, So this green stripe has 4 terabytes raw disk space, but one less, that means 3 terabyte capacity. Total capacity is 6 terabyte. Same as with 3 columns. Interesting, huh? But unusable space is now 1, 2, 3 terabytes. Wow! Now, because with 4 columns, because of more columns, we have faster virtual disk, same capacity, and more unusable space we can use with other virtual disks. So this is definitely better decision to use 4 columns if you chose Parity in this case, because you will get faster disk and more space to use by other virtual disks. Let's see the algorithm. Inputs of the algorithm are disks written at once or in one stripe, how many drives are accessed. Then capacity percentage out of this raw disk space, what percentage do we get? For example, in simple you get 100%, you get all the raw space, but in mirroring you get only half space. In Parity you get space of 1 disk less, so it's a ratio with number of disks. It's percentage of the raw space, so you can calculate actual capacity you get. Let's see how algorithm looks. We start the loop and we see we order the disks by the biggest one to the smallest one by free space. And then we see number of disks written is, for example, 3. Then we count from the biggest 1, 2, 3, third one, how much free space it has. For example, 2 terabytes. And then you allocate 2 terabytes from that disk and previous disk, so from first 3 disks. And then you erase that free space, we allocated it, and then you repeat the loop. Capacity is actually that allocated chunk on the disk times number of disks times capacity percentage. And of course, if you cannot find any free space, then you exit loop. Let's see that capacity calculator in the demo. We have here a stored procedure with inputs. And this inputs is resiliency type, simple, mirror, parity, double parity, then number of columns, and disk sizes. Disk sizes is varchar, comma separated value, and you say in gigabytes, 1000, 1000, 2000, for example. Okay, and the main loop is, these are all first checks, but main loop with algorithm is this while loop. It's very short. So we just select top disks written by 3 gigabytes descending, and we calculate the chunk size is minimal free space from these drives, and then we increase capacity by this chunk size, number of disks written, capacity percentage, and then we allocate that free space, we decrease free space by the amount we already calculated in, so we don't calculate twice the same amount. And when we don't have any more disks, we exit with this break. Output is 2 data sets. Total disks raw capacity, then how much leftover or unused gigabytes we have, and actual capacity what we can get from this virtual disk. And also per disk. Per disk is very useful because it's more detailed and it can be visualized. You can write, if you're a developer, please do write something that can graphically visualize this calculator, and I will be glad to include it in the video, to include the link in the blog. So that would be really awesome. Let's see how it works. For example, for simple resiliency, 2 columns and 2 disks, each 1 terabyte, we should be able to use entire space. Let's see. Yeah, total is raw disk space is 2 terabytes. We have no leftovers, so we used entire space. We can use entire space, and capacity is 2 terabytes, so we didn't lose anything. If we have 3 disks, terabyte, terabyte, 2 terabytes, then we still can use entire space, 4 terabytes, without any leftovers. If we have terabyte, terabyte, 2.5 terabyte, and 2 columns, we have raw space 4.5 terabytes, but only capacity we can use is 4 terabytes. Because on the last drive, this 500 gigabytes doesn't have a pair, because we write 2 columns here, because we said virtual disk is of 2 columns. That means we write always 2 disks, and we don't have a pair for this 500 gigs, and therefore we lose it as unusable space. Then, if we have simple resiliency with 1, 2, 3 terabytes, we can use all 6 terabyte capacity without any unusable space. If we have 1, 2, 3 terabytes with 2 columns, we also can use all the space, but we are twice as fast because of 2 columns. With 3 columns, we should be triple fast than single disk, but capacity is only 3 terabytes, because we have leftovers on second and third drive, unusable space. We could use it with some other virtual disk, but not in this one. Okay, let's see for mirror. With 1 column, we write to 2 disks. If we have 2 disks, each 1 terabyte, we should get 1 terabyte capacity out of raw 2 terabyte disk space, no leftovers. Let's see if we add 1 more drive with 2 terabytes. So we have 3 drives, 1, 1, 2 terabytes. We have capacity of 2 terabytes, no leftovers. Great, brilliant. Let's see for the same situation, 1, 1 and 2.5 terabytes. Capacity is 2 terabytes and leftover 500 gigs. Okay. Let's see parity. Complex example with 3 columns, which is a minimum for parity. We have 5 drives, 1 terabyte, 1 terabyte, 2 terabytes, 3 terabytes, and 4 terabytes. How much space we can use? Out of total 11 terabytes, we have capacity of 6 terabytes and 2 terabytes leftover. Leftovers are on first and last drive. Let's see with 4 columns, which is faster than 3 columns. We have same capacity, 6 terabytes, and 3 terabytes leftovers on last 2 drives. Interesting. And there you go, you can calculate any combination using this calculator. Let's go back. Now, tips. After you add a drive, that drive is empty. All the other drives are probably crowded because you bought empty drive to increase capacity. And now you have unbalanced data. To even out the data, you need to run optimize command from PowerShell. If you don't do that, if you didn't do that, you will not be able to use maximum capacity. You will get out of space. You can get out of space error. So you must do that. If you add a drive, run optimize command. Another thing, storage spaces has metadata, and that metadata takes, I don't know exact amount, but around 1 to 2 gigs per each disk and per each expand or create operation. That means total capacity, you must deduct that from total capacity. And if you do a lot of expands, each expand can take you 5 gigs, 10 gigs, not so small amount. That means you need to expand less frequent. You gives certain amount, you know you will not need to expand another, I don't know, year. And another thing, old thing, that terabyte is not terabyte. So you have, we have notation that disk manufacturers use, and that is with base 10 or 1000, and we have notation that is traditionally used in computers, in operating systems, which is based 2 or 1024. And both are like terabytes, but they are not the same amount of data, same amount of space. In fact, disk manufacturer's unit, terabytes, shows you 10% bigger number than operating system. For example, if you buy 10 terabyte drive declared as 10 terabyte, you will get in operating system 10% less, which is 9 terabytes. And this 10% rule is only if you express space in terabytes, not in gigabytes. So it works in terabytes. If you buy 4 terabytes, 6 terabytes, and 8 terabytes, you will get 3.6, 5.4, and 7.2 terabytes in OS from that drive. It's not cheating, it's different units used, but sometimes they are called the same, terabyte, and you don't know which one it is. I mean, you know, when you know this. And make sure operating system is patched, because there were bugs in the past, probably we have some bugs too. So it's good to patch operating system, to patch the storage spaces code, and to upgrade your storage pool. If it was created with older version, then it's good to run upgrade command, update storage pool, and then it will bring up this storage pool to the highest version, to the current version. Summary: we can add different size drives, mixture of different size drives into our storage pool, and even get away without any space lost. If you do have some space in leftovers, you can fill them with another virtual disk with columns equal 1. And use this capacity calculator you can download from blog sqlxdetails.com, and feel free to use it. For questions, more information, you can write me and visit the blog. Thank you very much for your attention, and see you next video. Bye bye.